In this video, we are going to discuss about second order high pass filter with unity gain. So this is how you have to connect the circuit. So for Y1 and Y2 you have to connect a capacitor, and Y3 and Y4 you have to connect a 1 by R3 and 1 by R4. Okay. So since for the gain I have connected it like a voltage follower, so it is called as unity gain. Why? Because this, if I consider this point is VB and this point is nothing but V out, so I can equate V out is equal to VB. Okay, so the input VB is your input and V out is your output, so both are same. So the gain is here, the gain value is 1. Okay, so if I solve, I will get the general form of equation of H of S is equal to y1 y2 divided by y1 y2 plus y4 into y1 plus y2 plus y3. This I have already derived. I have made one video on this. You can refer. Okay, so I am going to substitute this 4 values in place of y1 y2 y3 and y4. So if I substitute and replace S is equal to J omega, and S square value is nothing but minus omega square, I will get H of S is equal to minus omega square C square R3 R4 divided by minus omega square C square R3 R4 plus J2 omega C R3 plus 1. So here I can you can see in order to make the simplification, in order to make it the simplification in easy way, I have substituted SC instead of S1, SC1 and SC2. I have substituted like this. Okay. So this is how the equation is. So I am going to take tau 1 is equal to CR3 and tau 2 is equal to CR4. And I'm going to substitute in this equation. Okay, so I can write this as minus omega square tau 1 tau 2 divided by 1 minus omega square tau 1 tau 2 plus 2 j omega tau 1. Okay, so I'm going to take modulus of this value. So if I take h of j omega of modulus, I will get omega square tau 1 tau 2 divided by root of 1 minus omega square tau 1 tau 2 the whole square plus 2 omega tau 1's whole square. Okay, so I am going to differentiate this whole term by omega and equating that omega is equal to 0. That whole term I am going to equate it to 0. Okay, so I am going to differentiate this whole term. If I differentiate, I am going to take it in the UV method. Okay, so V I have to take whole square. So if I take whole square, the root term will cancel out, and I am going to equate it to 0. So this denominator term will cancel out. Okay, so now so you take the whole term, entire V term. Okay, this is your V, and you have to differentiate U. Okay, if I differentiate U, I will get 2 omega tau 1 tau 2. Okay, minus. Okay, minus this term you have to keep it constant, omega square tau 1 tau 2. Then I have to differentiate this whole term, and that is V. So if I differentiate V, I will get 1 by 2 of this whole term minus 3 by 2. Now I am going to differentiate this term. So if I differentiate this term, I will get 2 of this term into minus 2 of this term, omega tau 1 tau 2. Plus, if I differentiate this term, I will get 8 omega tau 1 square. Okay. So if I equate this entire term to 0, this whole term will cancel out, and this term and all, since it is 0, you will get root of 1, that is 1. And you can see this minus omega square is multiplied with whole term, right? So this everything will cancel out. Okay. And you will get only this term, that is minus 4 omega tau 1 tau 2 into 1 minus omega square tau 1 tau 2 plus 8 omega tau 1 square. Okay, so I'm going to take from this one 4 omega tau 1 common. If I take it common, I will get minus tau 1 tau 2 into 1 minus omega square tau 1 tau 2 plus 2 tau 1. Okay, this is what I will get. So now I'm going to this term will cancel out because it is 0, and if I substitute omega square, this is also will cancel out. That is this one also cancel out. Okay, so I will get 0 is equal to minus tau 2 plus 2 tau 1. So therefore I will get 2 tau 1 is equal to tau 2. So what is tau 1? Tau 1 is nothing but CR3, and tau 2 is nothing but CR4. So if I substitute, I will get this term, and CC will cancel out. So I will get R4 is equal to 2R3. Okay. Now from this entire term, that is this term, from this term, okay, what I'm going to do, I'm going to, instead of tau 2, I'm going to substitute 2 tau 1. Okay, so you substitute this value and you will get this term, and if I take magnitude, I will get this one. So I'm going to take a minus b the whole square. I will get 1 minus 2 tau square, omega square 2 tau 1 square plus omega 4 tau 1 4 plus 4 omega square tau 1 square. So these two get cancelled out. I will get h of j omega is equal to 2 omega square tau 1 square divided by root of 1 plus 4 omega power 4 is at tau 1 power 4. So I'm going to divide the whole term by 2 omega square tau 1 square. Okay. So if I divide, I will get 1 divided by root of 1 plus 4 omega tau 1 power 4. This I have to equate it to 1 by root 2. So if I equate this one to 1 by root 2, I am going to take the whole term is equal to 1. So that is why I will get this equation as 2. So I can write omega tau 1 power 4 is equal to 1 by 4. So from this I can write omega tau 1 is equal to 1 by root 2. So tau 1 is nothing but CR3. So I am going to substitute this. And if I want to equate omega at 3 dB, that is equal to RC. So I am going to equate this two term. So if I equate this two term, I will get R is equal to root 2 of R3. Okay, root 2 is nothing but alpha here. So I will get what is 1 by root 2? 1 by root 2 is 0.707. So R3 is equal to 0.707 of R. Okay, so and we know that R4 is equal to 2R3. Therefore, R4 is equal to 1.414 of R. Okay, so here I am going to substitute omega is equal to 2 pi f. Omega is equal to 2 pi f, and tau 1. What is tau 1? Tau 1 is equal to CR3. Okay, so we know that what is the relation between R3 and R, right? So what is the relation between R3 and R? R is equal to R3 is equal to R by root 2. R3 is equal to R by root 2. So if I take R3 power 4, I will get R by 4. So I will get R by root 2. If I substitute, I will get this 4 and 4 will cancel out. Okay, I will get 1 divided by 2 pi f RC. So we know that FL is equal to 1 divided by 2 pi RC. Okay, 1 divided by 2 pi RC. So if I substitute, I will get 1 divided by root of 1 plus FL by F, the whole power 4. Okay, so this is a transfer function you will get. Basically it is 1. The gain is 1. When the frequencies get reduced, the gain get reduced. Okay, so this is nothing but a high pass filter, and FL is a cutoff frequency. So beyond this one, you will get a pass band. Okay. So you have to make sure that If they have asked you gain or voltage gain, you have to substitute it here. And for this formula, you have to substitute, in order to find the value of R3 and R4, you have to substitute it here. And if they given the cutoff frequency, you can either assume the value of C, thereby you will get the value of R. So if I get the value of R, you substitute in this equation, right? R4 value is 1.41 of R. What is R3 value? R3 value is R by 4. Okay. R4 by 4. Sorry. R4 by 2. Okay. That is nothing but 0.707 of R.